So guys, in this session we are going to discuss about Deque operation and how to delete the elements from the data structure using front pointer and rear pointer. So as before of the previous session, so here I have written all the important conditions. So you must have to remember all these conditions because in the case of any type of examinations, they will mention this condition and they will ask you in which data structure it belongs to, or any other way of they may ask, right. So you should have to remember all these things. Okay, so I have written the conditions for how to use the front pointer and rear pointer if the deletion has to be happen. So now this is the first case. This is a Deque data structure. So in this, if there is only one element is present, so this is very easy. It will come as usual for the remaining data structures only. So if front is equal to rear, see, there is only one element present in the queue. So meaning is front and rear pointer are having the same index value. So f is equal to 3 and rear is equal to 3, isn't it? So if this condition is true, if this is true, we are going to delete that element from the data structure and we are initializing the value of f and r as -1. So what is -1? We are going to remove the pointers out of the data structure by giving a value as -1. Okay, so the same condition will come even for rear pointer operation. So now we will see the next case. See now the queue is full, that is the Deque is full. If it is like this, if we are using the prevalence for front pointer, how we are going to operate it? So that we are going to see, that is we can delete even by using rear or by using front. This is for front deletion and this is for rear deletion. So for that, what is the condition? If f is equal to 0 and r is equal to -1 or n -1. Now you check the condition. What is f value? Is this true? Yes, this is true. And what is r value? R is equal to n -1. What is r? So r is 3. For example, n is the size of the element, which I have said already. So n is, for example, 4. So 4 minus 1 is 3, right? That is, see friends, n is equal to 4 here according to this data structure. So 3 is equal to 3. So this condition is true. So the meaning is the Deque data structure is full. So by using the front pointer, we are going to perform the deletion operation. So here what will happen? So a will be deleted and we are incrementing the front pointer to the next successive element. So this will be pointing to this area. Okay. So is this clear? So now you see the same condition is going to come for all friends, but the rear pointer navigation will show the difference, right? So now if f is equal to 0 and r equal to n -1, the same condition. So if this is true, what we are going to do? We are going to delete the element present in the rear side, this one. So for example, let the value be here as it is front. So by using rear, I am going to delete the element. So what is rear value here? It is d. So after deleting this element, I am going to decrement the value. So d will be deleted. So I am going to decrement. So now r is going to point to this cth location. Friends, are you all clear? Please make a note. Next one, the next case is this one. If c, e and d, for example, rear pointer is here and front pointer is here. So what is the meaning? D is the front value, that is the first value, and r is the last value. So how I am going to delete this element? So if I use a front pointer, how? If I use a rear pointer, how? So for that, I am going to use this condition. See, the conditions are same. If f is equal to n -1 and r is less than or equal to n -1. So what is f is equal to n -1? So 0, 1, 2 and 3. So f is equal to n -1. So what is f value? 4 minus 1 is 3. So this condition is true, isn't it? So f is pointing to the last index value. Please make a note of it. So if this is present, if this type of a case is present, how to do? So f is holding the last value, that is the last index value of the data structure. For that, you should have to use this condition. So f is equal to n -1. Okay, if this is true and r is less than or equal to n -1. So what is r value here? So r value is 1. So this is less than 3. So this is the condition. So meaning is, friends, clearly understand, f is pointing to the last index value and rear is present somewhere in between the data structure. It is not either at the last or it is not either at the front. Suppose if this case happens, so please make a point, okay, if f is present in the last index value and r pointer, that is a rear pointer, is present in between the data structure, not either at the last or at the front. So if this is being given, how I am going to delete? By using the front pointer? Nothing. So see, I am going to delete this d. So d will be deleted and I will be decrementing the front pointer to this location. Okay friends, are you all clear? So like this only we are going to perform the deletion. So now we will see for the rear pointer. D, I think so. So front. So for this one, see, the conditions are same. See, f is present in the last and r is present somewhere in between the data structure. If so, by using the rear pointer, how I will be deleting? So rear pointer element is C. So I will delete this and I will be incrementing it to point to the next successive element, right? So r equal to r plus 1. Okay friends, are you all clear? So like this only we are going to perform the deletion. So now you see, next case is this one. So element is present in between the first and the last location. Okay, in between the first and last location, how to perform the deletion operation? Suppose if it is by using front pointer, this is the condition. If it is by using rear pointer, this is the condition. See, conditions are same. Okay, please make a point. I will tell you, if the elements are present in between the data structure array, that is not either at the front, not either at the last. If it is true, for that this is the condition. Okay, so f is less than r. So what is f value here? 0, 1, 2, 3 and 4. So what is f value? So f value is 1 and rear value is 3. Is this condition true? Yes, it is true. So 1 and 3, here also the same condition. So this is true and r is less than or equal to n minus 1. What is r value? So r value is 3 and it is less than or equal to n minus 1. So what is 4 minus 1? So you will be getting the answer as 3. So here also 3 less than 3. So if this condition is true, by using the front pointer, I will delete this b and I will move this here. Just I will be incrementing. So that is being written over here. So next, if you see for rear pointer, let me write here as it is. What I must have to do? I must have to decrement the rear pointer after deleting this d, like this. So r and f. This is the way you must have to write this condition. You can use here even less than. Both are right. Both are right. So some problem may occur, that is meaning is it will stop up to this. It will not check this element. So for that we can use less than or equal to or less than or equal to. Both are right friends, right? So use less than or equal to. It is far more better. Okay, so these are all the different conditions which we are using for front and rear pointer in Deque. Okay, so now how we are going to use the peek function by using the front and rear pointer. So what is the meaning of peek function? So friends, by using the peek function, I can able to retrieve or seek the current element that is being pointed out either by the front pointer or by the rear pointer by using one default method. See, for example, let me take this case. Okay, I want to see what is the element that is being present in the front location, right? So for example, let this array name be Deque. So how I will write this? Deque dot peek of f. If I give this, what will be the answer? So you will get as A. So this element will be printed on my screen. For example, if I use R, what will happen? The element that is pointed to by the rear pointer will be retrieved. So what is R value? So it is C. So that will be printed. So it is really very easy, isn't it? So these are all the very important points that we have discussed so far about DQ. Friends, I think so you will be having a clear knowledge. So now in the next video, we are going to see some of the important problematic questions that is going to arise in this topic. Okay friends, if you like this session, I request you all to please subscribe, like and share this channel, so that subscribers are really very important for us friends, right? Because we are working as a team to grow up this channel and help many students to get utilized. Okay friends, so bye and thank you.